Hey everybody, so I wanted to go through cladograms and phylogenetic trees in a little bit more detail. So open up the PowerPoint and let's get started. So here, this is a cladogram. And so the basis of this is that you want to have a hypothesis of the evolutionary relationships. So if I look at this cladogram right here, I can see that at the bottom, you always have your root, and that is your most common ancestor of all. So this common ancestor is the same for everybody on the tree. But as you go up, we have different traits. And these traits are what distinguish, and everything above it has to have that trait. So for example, developed from a blastula. Everything above it, everything on this whole tree has developed from a blastula. But vertebrate, so everything above is a vertebrate, but this one is not a vertebrate. Sorry, so messy when I write on here with my pen, but just want to make sure you get this basic idea. And then if I go to the top, I will see these two have the most in common with the most recent common ancestor. So these ones have the most in common. All right, so I'm going to show you how to create a cladogram. So the first little trick is that you want to count up the traits in common. So what I mean by that, here are my organisms and here are my traits. So I want to count this direction. So 3 of them have vascular tissue, only 1 has a flower, and 2 have seeds. This is basically going to tell me how to rank them. And when I draw my cladogram, whichever one has the most, that's going to be the first trait that distinguishes it. So vascular tissue. There is 1 that did not have vascular tissue, moss. So moss would be the first one that I write here. And whichever one has the least in common, we can also call that our out group. It has the least in common with the rest. It has none of the properties that the rest had. It doesn't have vascular tissue or flowers or seeds. And then if I go above that, the next trait that I want to distinguish out is the second one in rank. So that would be seeds. So who doesn't have seeds? Ferns. So ferns do not have seeds. So that's why they have to come before this seed property. And then the next property that I want to do, the last one, is having flowers. And who does not have flowers? Pine trees. Well, these also don't have flowers, but who's the next one to separate out? So pine trees don't. And then the one that does have flowers is a flowering plant or an angiosperm. So that's how you create a cladogram from a data chart. So let's do another one together, a little bit of a larger one. So here are all of my characteristics. And here are my organisms. So I want to do my totals over here. So who has a backbone? 1, 2, 3, 4, 5, 6 of them. Hinge jaw, 1, 2, 3, 4, 5 of them. 4 limbs, 1, 2, 3, 4 of them. This one is nice. It goes right in order. 3 of those. 2 of those. Oh, and not 1. There are 2 of these. That means 1 of these, I am probably going to not use 1 of them. We'll figure that out in a minute. So let's make our thing and let's figure this out. So 6 means the most had it in common. So that is the first one I want to write. So backbone. Then I say, okay, before it is my outgroup, who does not have a backbone, and that's the lancelet. Then the next characteristic would be the 5, so hinge jaw. And the one before it that had a backbone but did not have a hinge jaw would be my lamprey. And then 4 4 limbs. So tuna does not have 4 limbs, so that would go there. And then the next characteristic 3 of them have is an amnion. And the one that did not have an amnion was a salamander. And then the next property. Okay, so here I am left with milk and dorsal fin. All right, tuna has a dorsal fin. Oh, so I'm not going to use dorsal fin because I already used tuna. So I could put dorsal fin on here. It's the only place, if you had to write all the characteristics down, the only place I could write it as is on that line because it is appropriate for a tuna, but I couldn't put it on this main line because it doesn't work there. All right, so I want to use milk as my separator. So milk, the turtle does not have milk. And so now I am left with 2 organisms, dolphin and leopard. And so I could go like this, dolphin, leopard. I could have reversed that too and had the leopard here and the dolphin here. And again, I can use, because it would be something that would separate it. Dorsal fin could go on here. And that separates a dolphin from a leopard. All right, so that's how you do it. Here is another one. So we will practice again. So the way we do this, we got to find our traits. So here are the characteristics, which means I want to do totals this way. 3 have those properties. 4 have these. Only 1 here, 2 here, and 1 here. So again, there's 2 1s, so I probably will not use one of them, or one of them will not be on the main line. All right, so here is my main line. I want the 4 first. So this property, jaws, is going to be the first one that I do. The one that does not have a jaw will be separated out first, lamprey again. All right, and then the next characteristic would be number 3, that's the lungs. And the one that does not have a lung, sea bass. And of course, lamprey doesn't either, but I already separated them. Next comes number 2, that's a gizzard. And so who does not have a gizzard? Sea bass, already got it. Antelope. And then next, so next I need to decide, what do I have left here? I've got feathers and fur. Fur I already used for the antelope, so I could put fur right here if I had to use everything. But instead I can just go, all right, my alligator will go here, and then I can put my bald eagle here, and I could put feathers here, because feathers would separate the bald eagle from the alligator. All right, so that's how you do it. Now this one, this is called a phylogenic tree. And basically the biggest difference here is that it shows time. So it does show evolutionary relationships, but it also shows time. So present day to the ancestors. So like this is representing the most common ancestor of all, because this again is the root, the one that connects it. And then these, any points here, here, and here, these are called nodes, and those represent common ancestors. Now, it's only a common ancestor for anyone above it. So this is the common ancestor of C and D. This is the common ancestor of C, D, and A and B. And this is the common ancestor of all of them. The closer they are on a tree, the more closely related they are. So let's do one for an example. So here is my phylogenetic tree. The first question, a common ancestor of C and E. All right, here's C, here's E. So I have to follow it back down. The first place that they connect, the first node would be 4. So that would be the common ancestor for them. Which ones are extinct? So extinct means they haven't made it up to present time. So A and E would be extinct. Two species in the tree that are most closely related. So I need ones that are near each other. All right, C and D are the closest together because B really isn't very close to A, E isn't close to anybody. All right, what is the most recent common ancestor of B and D? All right, let me get a different color here. B and D. So I follow them down to the first connected node, and that would be a 2. All right. Let's go on to the next one. So this is actually from an AP Bio exam. So it says the amino acid sequence of cytochrome C was determined for 5 different species of vertebrates. The table below shows the number of differences in the sequences between each pair of species. Using the data provided, create a cladogram or a phylogenetic tree to reflect the evolutionary relationships between the 5 species listed, and then provide reasoning for the placement on the tree. So the first thing I want to do is I want to find any that are close, and I want to find any that are far. So what is really close? Ooh, this only has one difference. So the EF and the EA are going to be super close on here. And then I want to find ones that are far. Okay, this is definitely far. So, oh, and look, this D guy, he's far from everybody. This is going to be my outgroup. So we have a whole nother page to draw this on. So let's go ahead. I'm going to show you, actually, let me erase that. I'm going to show you how to do it both as a cladogram or as a phylogenetic tree. So I don't know the time to really do a phylogenetic tree, but I could do one of these and go, all right, my outgroup, I'm going to branch off first. So my outgroup first. So it was the D one. I got to go back here and see what it was called. D, P-O-L-Y, L-E-P-I-S. All right, that I'm going to branch off first, and I'm just going to call it DP over here, and then I'm going to keep going. All right, so now I'm going to figure out who comes next. So let's see, these two, 18 and 17 away from that. Okay, let's see, Gallus and this. All right, these are pretty close. So G and A, I want to be close, and I want the 2 E's to be close. All right, so I'm going to go like this. I'm going to make these 2 be close, and I'm going to make these 2 be close to each other. If I was doing it as a phylogenetic tree, I would do like that and like that. All right, and so I've got to look up their names again. All right, so EF and EA. They were only 1 apart, so that's why I put them so close. And this was the G and the AF. Okay, if I was doing this on the actual AP exam, I would write out all the names. I wouldn't use abbreviations. And it really, because they gave us a number of things in common, these had more in common, which is why I put them higher up. And that's why I put these lower down. And over here, as long as I show that these 2 have more in common and these 2 have more in common, which is why I put these 2 together and these 2 together. If you had reversed that or reversed these on the tree, still okay, still totally fine. All right, here is a multiple choice question that I found. So let's go through and do this together. So using this rRNA data, which tree is most plausible? So again, I want to look at these numbers and figure out what's really close and what's really far apart. Ooh, this one is really close. 2 is very few differences. So that's C and D. So I definitely want C and D to be close on my phylogenetic tree. And where's a far one? 21. So this is B and D. should be far apart. So let's look at my 4 answer choices. Is there anything I can cross off right away? This guy, they're not equal. There is no way these are equal. You've got all different ones coming out here. So I do not want that one to be my answer. All right, anything else I can cross off? Oh, they have B and D close. I want B and D far. That can't be it. All right, so I'm left with these 2 choices. All right, so B and D are far. B and D are, oh, look, this one's got D here and this one hit. Okay, so remember C and D, they can flip flop. So anytime you have a branch, okay, let me just redraw this. So B is down here, A is separated. If I have C and D here, this is the same thing as saying I have D and C. So my BD could be the farthest apart. This is definitely my choice. I don't want it to be the closest one here. I want it to be far. And I definitely want C and D to be close to each other. They're closest to each other on this one. Definitely this is my answer choice. Okay, the last one is a really big one, but I really, really like it. I also found this one online. So it says, now you're ready to construct it. So our last slide of all, you are going to actually make this cladogram. You're going to go from the very beginning of the data all the way to constructing it. So it says, examine the amino acid relationship for the part of the hemoglobin in the template below. You will be comparing the other animals to the humans and determining cladistic relationships based on this. So circle any differences in the amino acids from the human to the other species. So THR, oh, there's a difference, there's a difference, and there's a difference. Okay, so that's what I want to circle. All right, you're all the same, all the same, all the same. All right, so I'm just scrolling through here, trying to find a difference. Oh, these are all the same. There's a difference. That's a difference there, and there, and there. There's a difference. Okay, so I think I found them all. So now I go over here. All right, the gorilla. How many differences did I have? Just one. So I put a 1 in there. The horse. 1, 2, 3, 4 differences. The kangaroo. 1, 2, 3, 4, 5, 6, 7 differences. And this monkey, rhesus monkey. 1, 2, 2 differences. All right, this tells me how to separate it. So remember on the cladogram, the one that has the most differences comes first. So that would be my kangaroo. And I do not need to have a defining characteristic because it's just the number of differences. And then next would come the horse. And then next would come the rhesus monkey. And then next would come the gorilla. And last would come the human. So there we go. Based on the hemoglobin data above, which animal is most closely related to the human? So it would be the gorilla because there was only one difference. Only one amino acid difference. And then which one is the least closely related would be kangaroo because it had the most amino acid differences. And similarities in amino acid sequence means that there will be similarities in the DNA. Why? Ooh, this is due to codons. And the codons are from my messenger RNA. And that was transcribed from DNA. So recently, all of our research is really focused around the proteins, the DNA, the amino acids, the RNA, things that are part of the genome, because it is such specific data that we can get about organisms, and we can get a lot of that data instead of just like fur or arms or colorations, things like that. All right, let me know if you have any questions, and I hope that helped.